Hello everyone, Tom from EveryStepCalculus.com, EveryStepPhysics.com. Question about how do you graph a derivative? That was my big question too when I was first into calculus. Amazing why the professors don't really teach you, or they go over it quick so it doesn't really stick to you. They don't make you learn that or understand it. They just throw something up on the board and you're all by yourself as far as trying to figure out the concept. And it's not a big concept, but let's do it. Index 8 on my to get to my menu, and remember that a derivative is a slope of a line, but it's not placed on the curve until you use the equation y equals mx plus b, which we learned in algebra, which is the equation of a tangent line. So that's really what you're finding is because you want to graph this stuff and look at it, okay? And that's what I'm going to do here for you. Equation of a tangent line. Equation of a tangent line at a point on a curve. Point slope form y equals mx plus b. Going to enter the function alpha. You have to press alpha before you enter anything into these entry lines. I'm just going to use a simple. You can use any function you want, but for demonstration, I'm going to put alpha x squared plus 2 times x. I always show you what you've entered so you can change it if you want. I say it's okay. And we need to point on that curve to do it. So I'm going to do alpha 5. That's on the x-axis. X-axis is along the ground, if you want to picture it. So I show you what that is. And we say it's okay. First thing is you do the derivative, which is 2x plus 2 for this function here. And you're going to put 5 in for x, which I do. At x equals 5, the derivative f prime of f prime is called the derivative of f, which is a function. And so you enter in these quotation marks here, you put parentheses for your test or homework, because that's what, but I couldn't do that with the programming. So it actually, the m is equal to the 12 is equal to 12. And I used to say, well, what is 12? You know, remember there's a 12 over 1 on this 12 here. Okay, 12 over 1. That's rise over run, which is the angle. If you go on the y-axis up 12 points, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and you go over 1 on the x-axis, 1, and draw a line from that through the origin of the graph, that's the angle that you just found by doing the derivative. It's not tangent, it goes through the origin of the graph. I'll show you that in a second. Now, after we find the derivative 12, the slope, then at 5, we need to find the y value for, so the original function is x squared plus, what was it, 2x. So the 5 is entered for the original function for x, and then you come up with 35. So the point is really 535, x, y. They give you the 35 in most problems, but you just have to use the x value. That's all. I computed also, just in case they didn't give it to you. And then you put all that in for algebra and compute the formula, point slope formula. Y equals mx plus b. Well, here's mx, and minus 25 would be where the line crosses the y-axis, and that's way down here, 25 points way down here. It crosses the x-axis. So then it comes up here like this and then touches the curve. I'll show you that right now in graphing. We're going to quit here. We're going to get back to the home screen, and we're going to we're going to press the gold key and the F1. We're going to put in the function. You don't have to use alpha because you're using the calculator itself. X squared plus 2 times X. That's the original function. Now, just for demonstration, I'm going to put, notice that the m of x, we found the slope to be what, 12, I think. So if you're going to graph that, you just go 12x. So let's do that. 12 for the second y times x. Now, in the point slope form, there's mx right there. And then we're going to put what the equation was. It was mx minus 25, wasn't it? Yeah, so we're going to put 12 times x minus 25 in here. So this is the equation of the tangent line. Here's just the slope, and here's the original function. Gold key F3, let's graph it. Let's see what it looks like. Here's the original function. It's always a parabola, smooth curve in calculus. There's the what you found when you just found the 12. And here's the tangent line. A tangent line will go way up here and touch this point up here at x equals 12. We can actually go up and see that by taking the cursor, going up a little bit, up as far as we want, and then press let's graph it again, sorry. And press F2 and we use 3 to zoom out. And press enter. We'll graph all these things kind of zoomed out now. These points here are more than just 1 or 2 or 3. You can see here's the tangent line coming here. Here's the x value on the x-axis. Here's the y. Now let's take the right cursor and move it over till we get to 5. Now we're at 5.0, so close enough. And notice we're at 6 here. If we go up with to 12, that's exactly 5 and 12. No, not 12, but what was it, 25. That's where that's touching that curve right there, okay? Notice the x-axis crosses, that line crosses the minus 25 down here. So, have a good one.